Hello guys, it's your guy Viera from Viera Manufacturing Services. Welcome back to my tutorial. In this tutorial, we are going to be generating the M&G code required for VMS project 4. Hope you guys are excited because I'm very excited for this particular project. Though quite simple, no new context, it's just about revising some operation. Okay, so let's get started. So for Claire, we are going to be using mailing system, so I'm just gonna go fast. So project already saved, so Solicam 2.5D mailing. Okay, taking some time due to my computer. Okay, so I'm gonna go for internal equally. Let me just make sure I'm working in metric. Good. Internal. Okay, part name already exists. I did this project before, so that's the reason why. So let me just change the name. I'm gonna take VMS, let's say 4. Come. Okay, fine. Okay, so normal operation CNC controller. I'm taking the default one. Gmailing 3x coordinate system. Okay, I'm just gonna scroll down. I'm gonna make sure it's at, let me take top center model. Good. I'm gonna select surface and then just select over here. Okay, perfect. Making sure Z should be up and X should be inclined. Oh, fine, we are good to go. Okay. Okay. Taking some time. Okay, fine. Coordinate system or stock rather. So I'm gonna take absolute coordinate. I'm gonna take model dimension so it fits totally. So right now what I'm using box. As I told you before, if you use cylinder and you take absolute coordinate and you take model dimension, you notice that it doesn't fit properly. So this means clearly that you are using a lot of raw material to make, like you will use in actual life this could actually work. However, the raw material you have used, you have wasted a lot of raw material. That is what I'm trying to say here. You have wasted a lot of raw material. No need to take a cylindrical raw material. You rather take a rectangular raw material. So box model dimension, good, so it fits. Let's go. Target, it's predefined automatically, but if it's off in your software, no issue. You just come over here. The target is this, so this is our target. You could show target. Okay, perfect. Okay, we are good to go. So it depends upon you. You could change program number. I could decide this is VMS project 4, so program number 4, let's see. Again, database for the iMachinery. I could decide to use iMachine here, who knows. So let me just take some iMachinery data. I'm using steel, so I'm gonna go for free machinery steel 180. Okay, machine level, I'm okay with level 6. I go for the okay. Okay, taking some time. Okay, perfect. So first operation I'm gonna perform here, it's facing operation. I click and profile by mistake. Okay, so let's go for the face. Okay, geometry, no geometry is to be selected. Tool. I'm gonna use a face mill. I'm gonna swap this to inch, face mill 2 mm. I'm gonna increase the length, let's say 5. Okay, we go for the okay. Okay, all good. So making sure the coolant should be on. Okay, perfect. Levels. upper level already selected, so but it's this point. Okay, first step, I'm gonna go a little bit slower. Equal step down, you know the process. So let's just move on this technology. I'm gonna use hash because it's a rectangular block. If it's a circular block or cylinder, we are going to use quantum. So but right now we're using hash. I'm gonna take 50% of my tool. Right now, do I need any? Let me just take an up. No need for offset. Should I take offset? No need. I'm gonna reverse complete set. Okay, so I don't need any lead in. Okay, fine. I'm gonna save calculate. Let's look at this. It says simulation and G code are not available. Save operation failed. Why? Okay guys, so that error we are just from seeing, it won't show on your computer. I know if you observe when you press save calculate, that error did not show on your computer. So the issue was for my own settings, so I had to adjust one or two things. So but I won't show the adjustment in the tutorial, no need for that. Okay, a little tip. So what I actually did is, let me just close this. Okay, like I just pressed the Windows button and then I press R. We call it control run right for those that notice. And I came into the register. Okay, yes, just showing this. So I came under, you know, solid cam. Yeah, I came under solid cam and I changed some stuff here, like I changed the name. You see, so under it was solid cam 2021, so I put solid cam EEE. So this is just like, you know, making the software to start back from scratch. So I won't speak about that, so but just for your tip. Okay, so we are done here. So let's look at simulation. Solid verify. Okay, let me just push this, slow down speed. Too fast. Okay, as you notice, it actually redid the software from scratch, so I need to put back color. Not coming. Okay, let me just boot. Perfect. Okay, you could show data for time simulation too. Okay, good, fine. So I'm just gonna up this. I'm gonna look deep. So next thing I'm planning to do here is about, so what can we do here? We need to do these pockets, right? I'm gonna take these two pockets simultaneously. Okay, so I'm gonna come over. Let's use a new tool here. I'm gonna take pocket recognition. I think we haven't used pocket recognition before. So okay, so we are using pocket recognition for this tutorial. I'm just gonna come over here, new. So one thing I'm gonna do with pocket recognition, it gives me about 3 options: solid body, face, and then true pocket chain. I'm gonna take solid body. If I take solid body and I click on the 3D model, it's gonna select all the whole pockets in the design. So that's what I'm gonna do right now. So it's selecting the pocket, so any pocket is gonna select. So one thing I'm gonna do is, let me just check each pocket. This pocket is fine, this is fine, this I like too. I have no issue with this pocket. This fine. Okay, so I'll just press OK. You could see it over here too. So these are the pockets that have been selected. Okay, fine. So tool, I'm gonna use an end mill. I'm not gonna exaggerate on my end mill. I'm gonna take a small end mill. Yeah, 0.2 mm. I'm fine with this. I'm gonna use that. Let me just add the length. Okay, 5. Okay, good. I'm gonna take colon on. So let's just be fast on this. Levels. So right now there is no level with pocket recognition. There is no level at all. So you just need to put a step down. So 0.4. So the levels will be selected automatically. So no need to touch that. technology, quantum 5. Yeah, I'm gonna use an offset or a roughing pass. Okay, I'm gonna use finishing equally. I think we are done here. Link, let R, I need none. Yeah, I need none. Okay, let's try this. Save calculate. It will take some time. Remember that it selects all the pockets in the project, so it's gonna take some time. So actually, pocket recognition is actually used in project where we have a lot of pockets. You know, if we have a lot of pockets, it takes time to be selecting one pocket after the other. So we use pocket recognition. In this project, we got about 5 pockets. So it's not that much. We could use simple pocket operation, or again, we could use 2D machinery. I'm just giving you a brief, like, do not use pocket recognition because I use pocket recognition. You could use 2D machinery. Just play around, guys. Just play around. Try different methods. You know, just improve on your skills. Okay. So, but when it comes to complex, you know, projects, we are going to be doing some complex project around project. I think it's project 7. We got a lot of pockets there. Selecting even it's kind of, you know, it gives you headache actually. So over there will not be any option than using pocket recognition. We are going to see that in project 7 or 6. This is taking quite long. Okay, we are done finally. So let's look at the simulation first. Okay, let me just zoom it first. Okay, then let's look at this. It's gonna take some time. Okay, so the passes is properly done. We could see the pocket happening. So guys, as you notice, this operation is quite slow. Even with high-speed simulation right now, it's slow, right? So does it actually means that when in real life will it be this slow? Yeah, actually guys, it's gonna be this slow too. So for that reason, that is why we got introduction of things like 2D machinery for pocket operation. So if this operation could take, let's say, 5 minutes or 10 minutes to completion, now with the help of 2D machinery, we could reduce that time. Rather of using 10 minutes, we could say we are using 6 or 5 minutes, save production time. So if you are saving production time, this means you are producing more parts. So you just have to think in that manner. I'm just gonna fast forward the video up to the end of the simulation because we can't wait for the full simulation, you know. Okay guys, simulation completed. So right now, looking at the diagram, we are almost done here. So however, we got this rest material, and again we got this hole to drill. So I'm gonna drill the hole first, and then I'm gonna look upon this particular part. So let's do this first. So as you notice, only 2 operations, right? Facing and pocket recognition. Okay, let's go for the drilling. Where's my? I'm gonna be using drill recognition. A lot of recognition today, I guess. Okay, so we need to select the holes. It's gonna take some time. Okay, I'm just gonna come over here, auto find hole, making sure auto is selected, and then find hole. It's gonna find the holes in the part. Now again, this is a hole, this is a hole, this is another hole, and this is the 4th hole. And again, this big part is equally considered as a hole, but remember, this has already been machined by the pocket operation. So one thing I'm gonna do here, I'm just gonna scroll down over here, you know, let's just look category 1. This is hole 1. You see the way it selects 2, 3, and 4. So this is what I need. So I'm gonna, you know, delete the others. Okay, this is all what I need. Okay, you could preview it. So 1, 2, 3, and 4. Hope you got that. Okay, resume. Okay, we are good to go. Tools. I need to measure the dia. I'm gonna select this, and over here you could see the dia. It's it's 10 mm. Hope you saw that. So I'm just gonna come here. I'm gonna use a spark drill. Okay, spark drill of 10 mm. Okay, fine. I'm gonna increase the length to 80. Okay, we are almost done here. Coolant should be on. Okay, levels. So we are actually using a drill connection, so the levels are done automatically, but I want us to, you know, work something over here. I don't know where is that in. Okay, making sure that full dia should be activated. Full dia method should be activated. Okay, apply to all. Okay, go for the green tick. Technology, I'm gonna use a normal cycle, nothing to change here. Okay, fine. Save, calculate. Okay, simulate, solid, verify. Okay, go. Okay, perfect. Let me just slow the speed for you guys. Okay, good. Rest material. So hold, perfectly done, drilling done. Okay, so what is left right now, it's this particular portion. I don't know if I should actually give you guys this as a homework, because I do believe that at this level in point, you guys should be able to actually machine this particular part without my help. Okay, so let's just look at this. I'm gonna be using a profile operation anyways. Okay, I'll just focus over here. I'm gonna take profile. Okay, now one thing, I'm gonna come over here. I'm gonna deselect this, and take up to entity. So this is the portion where we have to go more deeper. So I'm gonna select this portion. Okay, I'm just gonna tick the green tick. Okay, my selection done. So there is something I could do more. Okay, maybe later on. Tool, I'm gonna take a more smaller tool. Remember that our tool was about 0.2 inch, right? And it wasn't able actually to remove the whole material. So right now we need a more smaller tool. So if we use 0.2 inch, so I'm gonna use a tool of 0.1 inch. Okay, levels, upper level. I'm starting from here. Depth up to this point. Okay, oh fine. So technology, I'm gonna make sure that this looks outward. It should look outward. So right now you go to right, it's looking outward. So it begins from here to here. Now for a proper finish here, I'm gonna extend this a little bit. So what I'm gonna do here is I'm gonna take one for some extension. One. Okay, why not two? Why not two? Yeah, let's just take two over here. Fine, perfect. Hope you are seeing this. So I'm gonna apply to our chain. Okay, perfect. Okay, so we are going to apply some roughing. Let's just apply some roughing over here. Okay, fine. Okay, finishing pass equally. Now it's step of 0.04, and again, I don't know, we could take an extension of 10 over here and a maximum step of 0.04. Okay, hope you're able to follow this. Okay, so we are good. Link, I'm using proper operation, so I'm going to take normal, and my normal will be 0.01. Let me just add 0.01, same as slit add. Okay, motion controller, all fine. I think all is fine. I'm gonna save, calculate. Okay, hopefully it's done. Let's look. Solid, verify. Solid, verify. Okay, let me just slow down the speed. We should go slowly. Okay, it's happening. We are seeing it happening. Okay, I'm increasing the speed right now. Okay, hopefully it's happening. Okay, perfect. Let me just on just a moment. I want to on this color. Okay, let's look at this. Perfect. Okay, rest material. Okay, very good. Perfect. Done. So guys, same thing applies for this site. I'm not gonna do the site. You guys are responsible for the site. So with this, guys, I can successfully say that we are done with the VMS project 4. So similar step applies for this side and similar steps applies for this side. Perfect. So guys, we are actually done with VMS project 4. Just press on that subscription button, like and share my video. Meet you guys in the next tutorial. Thanks a lot guys.